A very warm good morning to one and all. I, Preeti Yadav, Assistant Professor, Electrical Engineering Department of Medicaps University, invites you all to the webinar on recent trends in electric drives. Before introducing to the topic of the webinar, I would like to inform you about the proceedings of today's webinar. During the webinar, students are requested to put out the attendance into the chat box in the defined format. 10 minutes before the lecture ends, the participants will be provided by a feedback link into the chat box. All the participants are requested to fill the feedback form and submit it for the certificate generation. The participants will get the certificates within 7 working days. Participants can put up their questions into the chat box at the end of the lecture, from which 2 or 3 questions will be taken by the speaker and will be answered. So let us come to the today's topic of the webinar, recent trends in electric drives. Ongoing advances in power electronics helps to improve control systems within automotive applications. New developed or designed components enable more efficient systems, architectures, and controls. This webinar includes detailed study of different electric drive technologies and recent trends. This would be my honor to introduce our today's speaker, Dr. Shefali Jagwani. Dr. Shefali Jagwani received her PhD degree in 2019 from BMS College of Engineering, Bangalore. She is currently working as Head Power Engineering Center of Excellence and Assistant Professor in Department of Electrical and Electronics Engineering at NMIT Bangalore. She is a senior member IEEE and has 9+ years of academic experience and research experience. She has received many awards and recognitions. She is currently an executive committee member of IEEE PELS and IES Bangalore section and is recently nominated as a treasurer for Industrial Electronic Society 2021. Now, I would like to call Dr. Sanjeev Kumar Jain for greeting our speaker. Sir, it's over to you.
Thank you, Professor Preeti Yadav. So today it's my privilege to heartily welcome our very own Dr. Shefali Jagwani, because she has having long association with Medicaps University. So I welcome you, Shefali, for this webinar. I hope this will be a grand success. And thank you for your time. Thank you and welcome.
Thank you so much, sir.
So,
am I audible?
Yes.
Yeah.
Okay.
So, shall we start?
Yes, Evan.
Okay. I hope my screen is visible to all of you.
Yes, I think because it is visible to me, and I think it is also visible to others.
Yes, sir, it is visible.
Okay. So, I'll start with the introduction of the topic, that is recent trends in electric drives. As Preeti ma'am told, this is the modern and the most recent approach where we are working towards, all electrical engineers, mechanical engineers, all are working towards this topic, or this, we can say, in this area, many people are working. So our audience consists of most of the students year and final year, as I was informed. So about this topic, I will try to keep this topic as much as I can, and I will make it so that people from second year, everybody can get this topic is. So about me, I am Shefali, working in Nitte Meenakshi Institute of Technology, Bangalore, as an assistant professor, and also as an head of Power Engineering Center of Excellence. Regarding Medicaps, I am very much thankful for calling me for this webinar. It is my privilege to serve my alma mater. I have studied here, I have worked here, so it is very close to my heart, and I'm very happy to come back for this session. So we will commence today's that is introduction to electric drive, DC drives, types and applications, overview of an AC drive, introduction to switch reluctance drives, recent recent research trends in drives, and finally at Power Engineering Center of Excellence that is in my college. So I hope that slides are changing and you are able to see that. Can anybody confirm that? Slides are changing and you are
Yes,
right?
yes, yes.
Yes. So we will start with what an electric drive is. So if I talk in simple sense, simple definition, if we talk, a drive is nothing but a motor with a controller. So whenever we use a motor, we need to control it. We need to control the speed of the motor, or we need to control the torque, we need to control the flux, many other parameters are there. Basic, I will keep it little basic. So assume that we want to control the speed of the motor. So assume a simple example, assume a fan, you want to control the speed of a fan. So there is single phase induction motor inside it and you want to control the speed of the fan. You will use a regulator. So when a motor is associated with a controller, in simple words, we can tell it as it is an electric. So these electric drives can be of two types, that is fixed speed and variable speed type. So fixed speed is 75% drives, what we are using in our industries, and variable speed is 25% and still it is expanding. So for variable speed drives, we need power electronic converters in order to obtain the required speed regulation or torque level or desired speed torque characteristics. For all those things, we require special type of converters that is known as power electronic converters. I will come back to it in little detail later. But right now you assume the things that we are assuming a motor, we are assuming a controller, an electric drive, and this drive is being controlled with a converter which consists of power electronic modulator or a power converter. In the left side you can see a single DC motor with a controller. Just initial image in your mind, I have given one picture, and on the right side you can electricity in the industrial electricity consumption in various industries like lighting load is of 9%, other loads 3.5%, electrolysis is 10%, electric it is 2.7%, and rest all of industry is using electric drives, that is motors or motors with the controllers. So this is the load which industry is consuming. So we can see that electric drives is 50% of industry, which is electrical. So we can understand the importance of electric drive from this picture. Now, I will explain what an electric drive is. So, a typical block diagram of electric drive consists a power modulator, a motor, a load, control unit, and sensing unit. So, what does it mean? Assume you are driving a vehicle, a car or a two-wheeler, whatever. So that your motor vehicle is having one motor. That vehicle is your load and inside your vehicle. Now you want to speed up that motor. You want to speed up that vehicle. You want to give speed. What you will do? You will press accelerator, or you with if it is a two wheeler, you will by hand you will increase the acceleration. So what you are doing, your motor, your vehicle is running as let us say per hour, and you want it to be 50 kilometer per hour. What you will do, you will accelerate. So right now is your in whatever is your speed is 20 kilometer, but command what it is telling 50 kilometer per hour. I hope you are able to see the block diagram given on the left the slide. So input command is your 50 kilometer per hour. Control unit says no, right now it is 20 kilometer per hour. So we have to control it. We have to make it up to 50 kilometer per hour. So that command will be given to the power modulator or power converter. That according to that, that signal will change and motor, and motor will be running. Your in turn, your motor will be speeding up. But what is happening in this? You need something which is, you don't know what your load is. For example, if it is an electric vehicle, assume that it is an electric vehicle, it is not your normal fuel vehicle. So in your electric vehicle, what happens is your motor can be your induction motor, or your motor can be any other motor, PMSM motor or any other motor. But your source is a battery. Your source is a battery. So battery is a DC source, but your motor may be AC, maybe DC, maybe DC only, but of some other volts. Source is your battery. Battery is somewhere around 48 volts or something you can take for your electric vehicle. So if that much volts is there, your motor may be DC, maybe AC, maybe any other thing. Right now I am not going inside the motor. That topic I will take it later. Assume any motor is there, but if it is DC or AC, that power modulator will change your requirement of the, means that will modulate your source, your power according to the requirement of the motor. So if that is a DC motor, you can uh, assume it has to be DC to DC converter. If it is a AC motor, you can assume it as DC to AC converter. Like that, whatever is the requirement of the load, that is the type of the voltage that motor wants, type of the source voltage that motor wants, or the speed torque, desired speed torque characteristics that motor wants, or during braking or regeneration, whenever you are doing braking or whenever you are regenerating it, at what time, at that time whatever power is required. So all those things are supplied by this power modulator. So power modulator is an important aspect of an electric drive, which is nothing but a type of converter. Either it converts AC to DC, DC to DC, DC to AC, and uh, AC to AC. So these types of converters I have written in the last line, and I can show you these converters like this. So if it is a rectifier, it will be converting from AC to DC. If it is an inverter, it will be converting from DC to AC. Chopper, it will give DC to DC. Cycloconverter, AC to AC. AC voltage regulator, also AC to AC. But how will you come to know that what converter you want? So that will depend on the type of motor you have used and type of source you have used. So depending on the type of source and type of motor, you will choose a power electronic converter that will convert according to the requirement of the motor and the load, and it will give to your system, and that system will give input command to your feedback signal to your the power controller, and accordingly your speed will be achieved. So these power electronic converters are very important, and all these converters have switches inside that switches can be of MOSFET, BJT, IGBT, anything, any type of power electronic device. So what now, coming to the motors, what type of motor it can be? Motor can be DC motor, AC motor, and other motors. So DC motor, if we talk about, we have shunt motor, separately excited motor, series motor, PMDC motor, and compound motor. AC motor, if we talk, basically induction motor and synchronous motor. Other motors or the special motors, it comes as stepper motor, brushless motor, hysteresis motor, reluctance motor, and universal motors. So all motors have their different applications. Which motor is used where, we will see that when we go to the towards the electric drives in detail. So these are the type of basic type of motors which are used in our industry. Most commonly used is induction motor out of them, almost 60 to 70% motor which we are using is induction motor only. So this is the mostly used motor. Then what are the current trends in current trends of motors in industry? We can see that on the left side of the slide, you can see that induction motor, as I told, it is almost more than 85 to 90. Then PMSN motor, then we have stepper motor, then BLDC motor, then linear motor, and then if you see the right side of the slide, we have what type of performance these motors are showing. Like servo motors and servo drives, like if it is they show like they are 17% good, very good, their performance. Then 73% it is good, and 10% it is poor for the industrial applications. Similarly, they have given for AC motors and variable frequency drives. So we can see that current trends in industry, how we are using our motors in our day-to-day life or industrial market. When you talk about variable frequency drive market, we have all these AC drive, DC drive, and servo drive. Voltage range may be low or medium, and application varies from pumps, fans, compressor, electric vehicle, conveyor, lifts, HVAC, many other are there. And where we are using all those things, our end users are all the industries: automotive industry, food processing, oil and gas, minings, pulps and papers. And if we talk about geographically, almost all rest of means all world is using, whole world is using this, but the major consumption of this is variable frequency drive are mainly used by North America, Europe, Asia Pacific, and then it comes for the whole world. So I'll start with little about DC drive. So DC drive, many of you will be knowing that we have a back EMF equation here, that is EB is equals to P phi NZ by 60A. So we know that DC drive, what we have to do? We have to control that motor with the help of controller. So to control that motor, we should know the equation, like which equation, how we can control. So from this equation, we can see that this EB is there. EB is the back EMF of the DC motor. That equation is given, and your speed of the motor, we can see that speed of the motor is, last line you can see, directly proportional to your back EMF, whatever is given in the formula, and inversely proportional to the flux. So you can control your DC motor with either with the back EMF you can control, or you can control the flux. But back EMF is EB, which is nothing but V minus IaRa. So back EMF is dependent on your voltage and your resistance. If you are keeping both of them as constant, then only Ia will be varying. So if Ia is varying, if you control Ia, you can control your EB. So speed control of DC motor is dependent on voltage control, field flux control, and armature resistance control. So how these three control have come? That they have come from these equations only. So if maybe second year or so, if they are not knowing the equations, I'm sorry for that, but you will understand these equations whenever you will study further in your syllabus. So if these three methods, there may be more methods. These are the typically usually used methods which I'm talking about. So voltage control, field flux control, and armature resistance control. So if you control these things, by controlling these things, you can control the speed of the motor. I'm sorry for the figure on the left side. It is having the source which is not visible. Left side word is source. So from source, it is going to control and firing circuit. Then you have a controller within that. That controller is controlling the motor, and in turn, you are getting the current feedback in the control and firing circuit. And finally, your speed is getting controlled. So this is the typical explanation for the DC drive. But where when we are using this, like where do you want to use this? DC drive is basically most commonly used for your electric vehicle, your electrolysis purposes, and all those things. Majorly used is AC drive only, but to understand to understand that AC drive, but to research for that AC drive, we should be very much clear about DC drives. Nowadays, DC drives are coming back because of many other reasons, but in between, we can say you first was DC only. First, when we started with our electricity supply and all those things, it was DC only. Later, we changed to AC. Now again, we are going back towards DC. So I won't talk about that. I will just talk about a simple example of closed loop control DC drive. So the upper figure, it shows the control system diagram of DC drive. So I will explain that figure with the help of this schematic of for the practical implementation of DC motor control. So it is a closed loop control where you are controlling a DC motor with the help of your PI speed controller and your current limiter, and that goes to the current controller, and the current controller gives your signal to the firing circuit. Firing circuit will control your converter, power electronic converter, which in turn will turn on your motor or speed up your motor or give required torque to your motor in order to get your motor controlled. So when you have a closed loop control, you have a feedback system in that, which is controlling, which is giving inputs to your main controller. The error of your feedback signal and your reference signal will give the input to your PI controller, and which is controlling your drive in the system. So I am not going into too much detail because I assume that it is for second year students also, but it is a typical example where I can show the closed loop control of a DC drive. When you study it in detail, you will come to know the closer look of this. So DC drives, I told you, it is shunt machines. You can use in fans and blowers and lathe machines, series machine in cranes, hoists, elevators, trolleys, conveyor belts, then electric locomotives, then cumulative compound in rolling mills and heavy planers, elevators, etc. So right side, you can see a typical example of a lift system, four quadrant operation of a DC motor. So in lifts, you are generally using that. So if you can see, your first quadrant and your third quadrant shows the motoring operation, and your second quadrant and your fourth quadrant shows the generating operation. So for uh, first quadrant, you can see it is forward motoring. Your load torque is in right hand side, and your mechanical torque and your speed is in left hand side. The motor goes in the right side, it shows the forward motoring case. In the second quadrant, we can see that your power generating case. In your third quadrant, you can see reverse motoring, and in your final quadrant, you can see fourth quadrant, you can see your reverse generating case. So this is the four quadrant operation of a DC drive, how a lift works, a counterweight is there, an empty cage is there. This is a typical example of a DC drive which we take for understanding a DC drive. So I hope you will get that example in any of the book. You can try reading it, you will be able to understand. Then next, when we come to AC drive, if time permits, I will go back to all those things and I will explain in detail. I'm just giving you the gist right now. Time permits, I will go back and I will explain. So uh, AC drive, we can control that with the help of frequency, change of number of poles, and there is one concept that is known as slip. So what is that slip? Slip is nothing but your motor has two parts, we can say. One is rotor and one is stator. So stator is stationary part, rotor is rotating part or the moving part. When your stator is moving, the stator is moving means the electric field of the stator is moving. Stator is not moving, actually the field of the stator is moving. So when you are moving that uh, electric field of your stator, and rotor is also moving with its electric field, so the difference between the synchronous speed and your rotor speed is known as slip. So if you change that slip, if you change the number of poles, if you change the frequency, you have you can control the speed of the induction motor. It is nothing but ns is equals to 120 f by p. This formula we generally use for that. And you have your slip formula also, so that also you can use. Then this slip formula is dependent on, means with the help of rotor resistance control, stator voltage control, rotor voltage injection control. So these are the type of induction motor control that you are using for your AC drive. One of them, one example is given on the right side, that is stator voltage control. So you can see that on the stator of your motor, you have your AC voltage controller. This AC voltage controller, that is three-phase AC voltage controller, that is given on that. If you control the turn on and turn off of this AC voltage controller, if you control this firing circuit, finally you can control the speed of your induction motor. So this is one case, but this is not only the thing which we study in AC drive. Whatever I am telling is the basic control, but nowadays we are going towards that vector control of AC drives or vector control of induction motors. Scalar control is very easy, very simple to operate, but due to the requirements of the load, we are going towards the vector control, which is much more complicated than your scalar control. So vector control can be of your direct vector control and indirect vector control, where you have your AC motor, you assume it to be working as a DC motor. You have two-phase to three-phase conversions, three-phase to two-phase conversion system. You apply that system, Parks transformation and Clark's transformation, and then you assume that motor as that, and then you apply your vector control or field-oriented control. So that are little complex things I have not included here. Some other day we will talk on that. Right now, I'll go to the applications of AC drives. So applications means fans, pumps, compressors, machine tools, conveyors, centrifuge, paper machine, rolling mills, tube mills, diesel electric locomotives, gearless cement mills, power plants, etc. On the right side, you can see a belt and a conveyor system where your load is, or your carton boxes are automatically going or transferring from one place to another place with the help of conveyor belts. For doing this, you require some motor. So which motor here I have taken as the induction motor they are using it. Okay. Then I'll go to one special kind of motor. I have covered one DC drive. I have covered one AC drive. Now I'll talk about one special kind of motor, that is switch reluctance machine. What I am talking about this is a special motor. I have done my PhD on this machine only. I have my expertise on this machine. So I will talk little bit about this motor also. So this is a special case. This doesn't come under any AC or DC motor. It's a special type of motor where, see, in all other motors, if you have a two-pole motor or a four-pole motor, induction motor, DC motor, you have your number of rotor and stator poles constant. You don't have different stator and rotor poles. But what happens in switched reluctance machine is you have a different combination or a different number. You can see the figure on the left side, which shows the cross-sectional view of this motor, where you have eight poles on your stator and 6 poles on your rotor. So how it is different from other motors? First thing, the mechanical difference is there, where you don't have same number of poles in rotor and stator. Here you have different number of poles, that is 8 by 6 is this combination I am showing. It can be anything, 10 by 8, 2 by 4, anything it can be. Sorry, 4 by 2, anything it can be, any configuration you can choose. But the generally use is 8 by 6 or 12 by 10 or 8 by 6 and 10 by 4, like that combinations we generally use. So for this motor, you have we are assuming that the axis of this motor is inclined right now with at 0b, OB, we can say OB position is your axis. Assume that. So if we magnetize or if we excite one phase of the motor of the stator of the motor, my rotor will go to that particular direction. For example, you can see phase 1 and 1 dash. It is making two pole pairs making one phase. Okay, so that phase I am exciting so that my rotor is moving to that particular direction. So it is aligned position, middle position, and unaligned position. See the right side figure. If my stator and rotor are aligned in any SRM, whatever SRM is there, maybe this is showing the equal number of phases, poles in both the cases. If you assume that both are in the same axis, it is aligned position. If they are at different positions, it is in between intermediate position. And if they are totally unaligned in between of the two poles, it will be unaligned position. So depending on the position of the rotor, you have flux linkage characteristics. So see the down figure where I have showed flux characteristics. So if it is aligned position, you will see your uh, figure number 3. Then you have intermediate position, your figure number 2. And if you're unaligned position, your figure number 1. So all flux linkage characteristics are dependent on these positions. Depending on this position, you get the flux linkage characteristics. Once you get the flux linkage characteristics and your rotor position, you can control this particular kind of motor. So this is very special motor which you control with the help of, I have given only one leg of the converter. Depending on the number of phases, right now it is a 4-phase motor because I have 8 poles in stator. So the number of poles in stator divided by 2 makes the phases of that motor. So right now I have shown only one leg of the converter. So only phase 1 and phase 1 dash are being excited. You can see the green color in the figure, green excited one. So if I want to make the complete converter, I will add all these converters like that only. Phase 1, phase 2, phase 3, phase 4, all converters, all switches in series, and I can make a big converter that will be having 8 switches. So this is a special kind of power electronic converter, a symmetrical half bridge converter, which is being used for this control of switched reluctance machine. So I have an example where I have simulated this motor. So I have used this motor for as a generator, not as a motor. I have used this motor as a generator, and application for that I have chosen is wind energy. So I have taken a DC motor, which for that DC motor is working as a prime mover, or it is supplying energy for SRG, that is switch reluctance generator, in order to generate electricity. So I have used SRM, that is switch reluctance machine, in the generating mode as SRG in order to produce electricity using this DC motor as a prime mover, and thus that converter as asymmetrical bridge converter as my main converter for that. So we can see I have separately excited DC motor, which is coupled with SRG. I can see in the this block diagram, SRG is connected to this converter, and I have a generation bus here, which is connected with the load, and here I was able to generate the electricity. So this was my PhD work, which this is the photo on the right side is a real photo of my lab photo, whatever I have done there. And applications of for this drive is wind energy conversion system, aircraft generations, electric vehicles, blowers, fans and pumps, and gas turbine generators. Many other applications are also there. It is not as popular as induction and DC machine because very few people know about it, and the control of it is very much complex than any other motor. If I get chance someday, I will I hope you know that I'm basically from Indore only. I have studied all my degrees from Indore except for my PhD. So I was in Medicaps in 2009. I passed out from there. 2009 to 11, I was in SGS ITS. I did my MTech. And after that, 11 to 13, 2011 to 13, I taught in Medicaps as a faculty. Then From 2013 onwards, I was in Bangalore, where I have done my PhD, and right now I am at NMIT. So whenever I will be there in Indore, if some chance is there, I will come there. I will explain my whole topic with in detail. So it is a complicated machine, but right now very much it is in research. If somebody is interested in the projects or in the research on this particular topic, please take it up as a project. It is very much interesting for now, like whatever electric vehicles we are using nowadays, it is competent for all other motors, and it has its many advantages. But its control issues are controlling is little tough because it is not as popular as other motors. But rest all things, it is very interesting for all the um, motor manufacturers, those who are and one thing I want to tell, when I wanted to buy this motor, I was not getting any vendor in India. I was not getting this motor. I have given as a special order to make for some vendor, and they agreed and they have made it. So you can see the uh, type of market availability which is required for this motor to make it popular. And advantages, if you ask, yes, it has many advantages because it is having high torque to inertia ratio, low inertia. It is very robust machine. It doesn't have any permanent magnets in rotor. It is no permanent magnets or no windings in rotor. Construction wise, it is very simpler than AC and then DC motor. But only issue was the control issues. But due to the advancement in electric drives and power electronic systems, it has become a very much interesting topic for all the researchers. So if any one of you want to take the project, please go ahead and take it up. Any problem is there, you can contact me also, and Sanjeev sir is there. He is my teacher, so you can contact him also for anything you want help from them. Then it uh, I have talked one type motor for everything. Now I'll tell you what are the performance criteria, like how do you evaluate motor, how do you select your drive. This is the top 10 evaluation criteria. Reliability should be more than 70%. Performance is 65%. Then you have control, that is 54%. Programmability in software, 53%. Like that, maintenance 42%, and convenient of operator interface 37%. So like that, you have many parameters. Depending on these parameters, depending on these numbers, you can choose which motor you want, which drive you want for one particular application. Now, coming to the application, recent trends in drives. Till now, I was talking totally technical. Now I will not sound technical. I will sound something of your interest. So that is e-bike. When we talk, you can just see left side of the figure. Left side of the slide. It is a figure of an e-bike. This is a prototype made by Switch company. So right now, whatever bikes are already available, they are up to 65 kilometer. They can go for a single charge, but this is a prototype. This they have made it, and they are trying to make it a success. Still now it has not yet come as a commercial bike, but prototype is a success, where they are assuming that it will go up to up to 150 kilometer per charge. If you charge once, it can go up to 150 kilometers. When we talk about electric vehicles, the very much important thing is we should understand why electric vehicle is required. So that I hope everyone is understand that we are running out of fuel, we are running out of petrol. You can see 100 rupees. I don't know about Indore, but right now Bangalore, we are having 100 rupees per liter is a petrol cost. So fuel is we have deficiency. We can run fuel after some years. So for that we need one option, that is convenient option, that is electric vehicle can be an option. But why it is not till now, why it is not being popular? Because of these issues, charging issues. If you want your electric vehicle to charge, you have charged at your home, but you are going on a highway. After 65 kilometers only it is getting discharged. What you will do? that much charging infrastructure, charging facilities, all those things are required to make it a popular. So here the infrastructure changes are being done by the by government of India. So for them, it is not very easy topic, but research is going on. We are towards that. We have government has told by 2030 they want to replace almost 70% of the vehicle or almost all vehicles with electric vehicles. They have that target. They are working towards it, but we have lot of issues, challenges like this. So this is the prototype, which is this is made in UK. This is not Indian. So this is made in UK, where they are claiming that it can go up to 150 kilometer. So we can have lesser number of charging stations rather than more number of charging stations. But it is just a prototype. Still, that research is going on, and it is being designed. It is known as the most coolest bike of the year 2019. Then right side, you can see an electric train. So this is a bullet train, which is being used in US and all other countries. In many other countries, you have UK, Europe, many other countries, Japan, you have bullet trains. But this, whatever I am showing here, it is a recent advancement where this train is running with the help of solar panels. Solar panels, you know that they have they can collect the energy in the form of DC. Then you can have DC to DC converters inside your drive system in order to run your DC motor. And finally, your whatever load will be there, whether it is a train or a vehicle or whatever, it can run. So other examples, these are the typical examples we are like we already use. For a paper mill, you can see on the right side, we can have so many rolls are there. So all are rolling with the help of machines, and all machines are being controlled with the help of a drive system. Here, ship loading system, you can see left side, where you have a crane for attached with the ship for uploading and downloading of your whatever goods are there. In order to control that crane motor, we are using a motor with the controller. So it can be induction, it can be shunt motor, anything. Then when we talk about Airbus, so you can see Airbus is there. So there are many parameters. I think if I talk about a normal car, you have more than 200 types of controls in a normal car. I'm not talking about electric vehicle. Normal, whatever is the existing ICE car, you have almost 200 types of controls. So electric car, that means you have more number of controls. When you talk about one Airbus, you see the number of controls. So many controls are given in the whatever is given in the small letters. I'm not highlighting that, but whatever is in the given is in the red color. I've highlighted few of that. So you can see you have cabin air compressor, electric starter generator, boiler pumps, electric motor pumps, electric water generator, fans, many things are there. So all those things, to run that, you need a motor with a controller. So all the types of motor, DC motors also are being used in this for different purposes. So you can see the amount of drives research and motor research is required in order to make the things better. It is not there that if it is already there, you cannot do it anything. It is not like that. Once we have got something, we can always make it better. So there is always a chance of improvement. So any topic on this can also be taken as a project or a research thing in order to improve the efficiency of some particular part of a Airbus or a electric vehicle or a normal ICE vehicle, anything. So when we talk about this, other recent advancements in drives. Sorry for the left side of the, it is cut. It is written as wind generation, and below it is a wheel of an aircraft. There you can see a motor which is being controlled with the help of the controller and the torque sensor. Wind generation, you all know that you have a wind generation there. So you will be using a PMSG motor generator or induction motor generator here. And I use for wind generation switch reluctance motor there as a generator. we have washing machine. There are many washing machines are using universal motors, but along with that, you have other types of motors also people are using in that, and it is controlled by IGBT devices. Then you have a drilling machine. There also you have a controller and a motor. Wheelchair, it can be any motor we can use. Nowadays I have read some papers on SRM based, switch reluctance based, this wheelchair. Hand sanitizer dispenser, it also have a small DC motor inside that. On the right side you can see electric vehicle. Electric vehicle we haven't talked much, so I will give you one example here. So you can see an electric vehicle with a solar panel on the top. So this solar panel is collecting your energy, solar energy. It is giving this energy in the form of DC to your DC to DC converter. DC to DC converter will convert your energy into your required energy of your motor, and your motor or your electric vehicle will run. But when you want to store the energy, what you will do? You have to go through the battery. That energy is not directly supplying to the motor. It will be stored in the battery, and battery is giving that energy to your motor. So for that you have a different approach here. Battery you can store in super capacitor or ultra capacitor, or you can have fuel cell option. You have many options there. So here also there is a scope of research or projects here, where you can have a fuel cell operated car, or a super capacitor operated car, or a battery operated car. uh, if you don't know, I will tell you what is the difference between a battery and a super capacitor. When we talk about battery will give us an average power. But when we talk about a super capacitor, when you have to suddenly apply brakes, or when you have to suddenly climb on a hill, you want more power. Or if you want to suddenly apply a brake, you want less power. So when you require sudden charging and discharging, you will be using a super capacitor. But when you want an average speed to be maintained, you will be using a battery. So when to use super capacitor, where to use battery, all those things can be optimized. It can be taken as a research topic. Many researchers are already doing on it. You can also take up as a small project in your final year, or as mini project, where you can uh, work on this electric vehicle BMS, that is battery management system. That is very important parameter, where it monitors everything: temperature, SOC, that is state of charge of battery, SOH, that is state of health of battery. Many things they will monitor, and they will tell, okay, this battery can go up to 25 kilometers more from here. After that, you can charge. So there are many things which are connected with this drive system. It is not only the motor and controller we are doing research on. Many things are connected with all those things, and you can take any part of the vehicle, or any part of any other application on which you can make a small project, or a simulation, or a hardware based project. Now, what are the research trends in electric drives? So I have told already about the SRM. So SRM, you saw that you always want to measure or find out what is the position of the rotor, where it is: aligned position, unaligned position, or intermediate position. So you always want a position sensor there. Along with that, you want a sensor to measure the current speed of that motor. So there are many things going on in the research that is known as sensor research, where you don't require sensor. You have some special techniques where it does the work of the sensor only with the measurement of the initial parameters, and it doesn't require any other sensor to control that. For example, if I want to measure the torque of the induction machine, or a SRM, or a DC machine, I want a torque sensor. So for that torque sensor only costs around 4 lakhs or something. For when I asked for SRM, it was around 4 lakhs. So you cannot afford for everything. You cannot afford a sensor. So in my project also, I didn't had to buy a sensor. I had used this method in order to position and the speed of the motor. So, but if you can avoid the operation of the sensor, you can use many other sensorless controls like this, and you can do your research or you can make your project. Then control of variable speed drives, that is one another topic. I have already told you so many examples of variable speed drives till now. Then it comes to IoT based control. For example, your electric vehicle is there. So that comes for your, we can say, charging. Electric vehicle has come to your charging station. You have a charging station. Now, what do you want? You don't want somebody, like in your petrol pump, who some person is there who is filling petrol in that. No, you don't want all those things. What you want is, you want everything to be automated. What you will do, you will make a charging station in such a way that the person with the car comes there, puts the RFID card or some identity card, whatever, which has all the barcodes or RFID thing, where he can show the identity of the owner and the vehicle of the and the vehicle, where it will tell the details. Oh, this is the name of the owner, this is the vehicle. Then it will ask you that digital, we can say, module, that will ask you, what do you want, how much charge do you want, how many more kilometers you want to go on this highway. So for example, you want to go 100 kilometers. So you don't know how, for 100 kilometers, how much it to be charged. You will put 100 kilometers more. That at least you can see with your Google, how many more kilometers you have to reach. You just put that 100 kilometers more. Then for 100 kilometers, your you will give that input to your vehicle inside that, along with the battery management system, automatically it will calculate, okay, for 100 kilometers right now, this is the temperature of the battery, this is the state of charge of the battery, this is the health of the battery. So for 100 kilometers, how much do you want, how much do you want to charge it more? Okay, we want to charge it for 15 minutes. That amount they will give it in the time, uh, according to the specification of the charger. So charger specification will be induced in that, and your the number of more kilometers you want to go, only that data, if you put it into the digital module, all things will be automatically calculated by your BMS, and you can charge according to how much more kilometers you want to go. Then you have, once you charge that, then your whole data will go to the charging station owner. What he will do, how he will come to know, okay, this fellow had come, this has charged for that many minutes, this fellow has paid this much amount with the help of their RFID card. So everything can be cloud based or internet based, where you can control everything. So this is one more topic where you can work on your projects, like how you will make it totally digitalized, how that car is coming, how that is being charged, how you are monitoring all the parameters of your vehicle, how that vehicle is using the motor, what is the condition of the motor, all those things you can find out. Then regulation on energy efficiency, what energy efficiency, like how much it is efficient, how much we can work from it, what is the energy efficiency of that particular drive. Then vibration control, we have to work on it. It is also a research topic. Then artificial intelligence and machine learning supported drive, that we have to work. Artificial intelligence and machine learning, that also same, almost same example I can take with what I have taken with IoT. You can just put whatever, you can just think on it, whatever you want, how much ever you charge you want, just do it with gesture control. Just put a gesture, okay, 10 kilometers, it will do according to that. Just with the help of gesture, it can be controlled. That are all futuristic things that have not come now. I'm just telling the scope of research in this area. Sizing options, always size of motors is a concern for all the researchers. You can try to reduce as much as possible. Smart grid, it will come when you talk about smart grid. Smart grid means it is a two-way communication between the user and the company, like MP, electricity board, or any other electricity board. So it is not only you are taking from from the company, you are. So when that happens, in simple words, two-way communication between the consumer and the company is known as smart grid. So whenever you are producing more energy, if you have a solar power plant or if you're a wind plant in your commercial campus or in your home, you have a solar power plant, you generate the energy, you give it back to that. But for that also, if you have an electric vehicle at your home, you are charging that vehicle should be connected to the grid, vehicle to the grid, and grid to vehicle communication should happen. So there you have a scope of doing the research. And of course, last but not least, productivity and availability is always the first priority. We as an and I would say the first priority is availability. It should not be, and also the affordability. It should not be very costly, and it should be available for all types of and all categories of all communities, all people. It is not only for the hi-fi people or for the only for the as a taxi or something. It should be available for all. On right hand side, you can see a fully electric vehicle, which is launched by Tata Starbus in 2019. So till now, whatever before this had come, it was like it was not fully electric. It all the buses, whatever before it was a hybrid vehicle. Means along with your fuel, you were using electric vehicle. It means it was hybrid, but now it is fully electric right side bus. So you can see that is a Tata Star bus. So it has come, it is launched in India, everything is good. But the thing is, no, I really appreciate that. But the thing is, this is somewhere I read it is in this amount is in crores, almost 4 crores or something. I'm not very sure, but it is very costly. This vehicle is very, very costly. So it should not be like that, because government also has to buy, and government has to also to supply to all public transport facilities. So in order to make it affordable, there is always a scope of research. It is not like it has already come, then what you will do. It is not like that. We always have a research scope, we always have a project scope to do that, in order to make it more available, more productive, and more affordable for all. So I think I am just showing the last 1 minute video. Just 1 minute. Is it visible? Is it visible?
Yes,
Can
but it's not working. Only still is there. No, I think the video has not turned on.
uh,
It's looking like a picture. Black screen is there.
okay. Uh, 1 minute, sir. Now it is visible. YouTube is opening.
Still not, I think.
Ma'am, actually, you have to share that screen too. Still, we are able to see your PPT screen only.
Okay, I'll just 1 minute. I'll do that. Now,
Yes, yes.
Yes, ma'am, we can see it now.
I think you all just 1 minute. I think you were able to see the video. I don't know about audio was audible or not. I don't know, but I think you could read that.
Yes, ma'am.
Okay, so that was nothing but a futuristic, we can say, assumptions, or Amazon has come up with this prototype where we have an autonomous robo taxi, where it is a robot which is driving the taxi, and all the control of the robots are being done by various motors, including BLDC motors, stepper motor, DC motor, and many other types of controls are there. And you can see that that doesn't require any driver. Everything is automatic, and that is where we are heading towards. So I think I'm well within the time. And just last slide I want to discuss. This is the facilities. I think you're able to see my screen again.
Yes.
Yes, ma'am.
Yeah. So this is the last slide where I want to talk about the facilities available in Power Engineering Center of Excellence, NMIT Bangalore. So this Center of Excellence was inaugurated in 2019 September. Then from September till last year March, that is 6 to 7, 8 months, we worked in this center. It was just a startup kind of thing, starting center. But then again lockdown happened in March 2020, and again we are uh, active in this center, where we have 5 user license of ETAP, 15 user license of ePlan, 5 of MyPower, then ARM DSP kits, Keel software, anyway it is available, then Cypress University program, then a ARM University program, then we have 30 computers where we have all those things. LCD projector is okay. Then you have power system protection kits. Then we have FPGA kits and FPAA kits, that is field programmable analog array kits. So these are the facilities available in Power Engineering Center of Excellence. What we will do here is with this softwares and with this things, we have not explored everything, but almost 3 4 things we have started with. So for that things, what we do is like ePlan and ETAP and MyPower and DSP. What we do is we give value-added courses to our own students. So only 8 months were there when we worked earlier. We had started with our own students. We give value-added course where we give uh, additional certificate. We give 30 hours training with the lab only. Wherever they have a lab free, every week they have one free lab in their timetable. In that lab we give this value added course as the option they have to do. Those who are coming for that lab, we will give a 30 hours training certificate for them, so that it can act as a skill development for them. And whenever they are going for jobs in the companies like ABB, Schneider, or any core electrical company, all of them majorly are using this ePlan and ETAP software, so they can be employed in that. So for that reason we have started with value added course. And from this year onwards, now we are planning, once everything is back to normal, now we will plan for internships for outside students also, in very minimal fees, where they can access all those software. They can stay here for 10 15 days, whatever will be the program decided. We still have not framed the guidelines because it is a very new center, but we will do it shortly, and we will communicate to you people also. If any students are interested, they can come here, explore the opportunities in these software, get their skill development certificate, and along with that enjoy the weather and the ambience and the environment of Bangalore. So I welcome you all for this. In case anything is there, I will communicate with Sanjeev sir and all other faculties of Medicaps, and I think we will be in touch in future also. So that's all from my side. Thank you.
Thank you so much, ma'am. If any participants have any question or query, you can put into the chat box.
So I think that that was a very nice presentation. I am having a question, Shefali.
Yes, sir.
Can we compare this SRM with BLDC? Can you comment on this?
Yes, sir. This is actually the most common question that comes up. Yes, sir. We can compare. Like BLDC is actually more suitable for electric vehicles. Specifically when I'm talking about specific electric vehicles, it is more suitable. But what happens is when we talk about the uh, torque to inertia ratio or the robustness and all those things, then SRM has lead on that. And along with that, when we talk about the constructional aspects, we don't have anything in rotor, no permanent magnets, no windings in rotor in case of SRM. But BLDC, it is not like that. So if that motor comes up in bulk, right now that motor is costly. I told you when I ordered for myself, it was like not possible, not available only anywhere. But when we talk about that production in bulk, definitely it will be very much cheaper than all other motors. But that power sorry, that control issues should be that much easy that we are able to produce it in bulk. That is the only thing where research is going on, and many companies are working on that. So
Okay.
BLDC is already used, SRM is trying to overtake it.
Okay, that's very correct. So, uh, Preeti, can I?
Yes, thank you so much, ma'am, for delivering such a nice webinar and sharing a lot of information that put our participant very successful for having this successful webinar. And there were some informations regarding the BMS system and EVs. Actually, we are having some students in our university, they are doing project on battery management system. So this webinar will be very helpful for those students. Thank you so much, ma'am. Now, at the end, I would like to invite Dr. Sanjeev Kumar Jain for delivering the vote of thanks. So please, over to you.
Thank you. Thank you. So I am here. I, Dr. Sanjeev Kumar Jain, Assistant Professor, Electrical Engineering Department, Medicaps University, is very much thankful to Dr. Shefali Jagwani for providing the insights in the SRM motors, and with her expertise and work on real environment. So I am very much thankful for that. And I am also very much thankful to our Honorable VC sir and the management and the HOD and the electrical department for providing the facilities and the permission for conducting this webinar. And I'm also thankful to the organizing committee of this webinar, Medicaps University. And last but not the least, I'm very much thankful to our audience, which are from various institutes, professors, and our very own students of second year, third year, and final year. So I think they will have a drive to work in this area and will learn a lot from this webinar. So I am heartfelt thankful to each and everyone associated with this webinar. Thank you very much. So all have to fill the feedback form, and I'm going to end this webinar after 1 minute. So thank you very much, Shefali, once again.
Thank you, one and all. Thank you, Sanjeev sir, for giving me the
Yes.
opportunity. And please convey my regards to Somani sir, Pal
Yes,
sir,
yes,
Rajesh
yes,
Arya sir, and
yes.
all my teachers. I'm very much happy and thankful to all of you. Thank you so much for giving me the opportunity.
Thank you for associating with this, sir, with us, and thank you for
And
this
thanks to
coordination.
Amrita Mantri ma'am and Prashant sir. All
Okay.
I think all are there. Thank
Correct.
you very much, one and all. If I'm forgetting any one name, please excuse me. I'm very much thankful to all of you. Thank you.
Yes, that is so nice of you. We always remember you and your batch. It was a very nice batch for all of us working over here. So thank you, Shefali.
Thank you. Thank you, sir.
Okay.